I had somebody request a video on proofs for the HL math, and it's impossible to do all of proof in one video and not have it be an hour or two long. Because proofs can be on any content, and it can come in a couple different ways. So here, I'm just going to focus on a couple different types of induction, and then in another video I can talk about proof by contradiction. The third type of proof of a direct proof, it really depends on what they're asking you to prove, and usually you're just writing down definitions and then doing some algebra. So all of our induction proofs are going to follow the same three-step process of starting with the base case, then writing down the induction hypothesis, which usually involves just copying and pasting the statement that you are asked about. And then step 3 is looking at the next step, the n+1th step. So, for example, let's try to prove this statement here. We'll try to prove that 2 to the n+1 is greater than n squared. N is an integer, and n is greater than or equal to 3. Okay, so our base case is starting with n equals 3. 2 to the 3 plus 1 is 2 to the 4, which is 16. Compare that to 3 squared, which is 9. 16 is greater than 9. We're good to go there. Step 2. You write assume that 2 to the n+1 is greater than n squared for some n, for some integer. In step 3, we consider the next step. And the next step is going to be 2 to the n+1 plus 1. Well, we don't write down that that is bigger than n+1 squared. We have a goal. You can put it in a little side box. Your goal is that this is bigger than n+1 squared. Okay? Which sometimes it's nice to write out that n+1 squared is the same as n squared plus 2n plus 1. Okay? Now, 2 to the n+1 plus 1 is the same as 2 times 2 to the n plus 1. Add an extra plus 1 in the exponent. And we know from our induction hypothesis that 2 to the n plus 1 is greater than n squared. So we know that this is greater than, let me back up for a second. We can say that this is equal to 2 copies of 2 to the n plus 1. So this is equal to 2 to the n plus 1 plus another 2 to the n plus 1, which we can say is greater than n squared plus 2 to the n plus 1. So all that remains for us to do is to focus on this part, 2 to the n plus 1 compared to 2n plus 1. Okay? We can do a very similar thing. I'll just do it over here on the left side. That 2 to the n plus 1 is 2 times 2 to the n. It's 2 to the n plus 2 to the n, which is greater than 2 times n plus 1. Because n is greater than 3, greater than or equal to 3. We know n is greater than or equal to 3, so 2 to the third is bigger than 2 times 3. 2 to the fourth is bigger than 2 times 4. So we can say that this is greater than the entirety of n plus 1 squared. Okay, so that's one example of induction. Another example of induction would be something like proving some sort of a formula using a sum. So let me look at this here. Okay, I'm going to pause for a second. So we've got another example of an induction proof with a sum. So we are going to prove that the sum from r equals 1 to n of cosine 2r minus 1 theta equals sine of 2n theta over 2 sine theta. And we are given, they gave us some other formula, we are given that 2 cosine A sine B is identical to sine A plus B minus sine A minus B. Okay, so let's start with our base case. Our base case, we start with n equals 1. If we make n equal 1, then the left-hand side is just the first term of the sum. So it's just cosine of 2 times 1 minus 1 theta, which is just cosine of theta. And the right-hand side is sine of 2 theta divided by 2 sine theta. If you use the double angle on the top for sine, that's 2 sine theta cosine theta over 2 sine theta, and you can see why the base case is true. Cancel the 2's, cancel the sines. Now we're going to do the induction hypothesis. So this is where you would say, assume that this is true for some n. I'm just going to save myself space or just say it out loud, but on the test you're going to write down, assume this is true for some n in z plus. Okay, so then step 3, we're going to consider, my pen is failing me. Okay, let's try that again. Consider the n plus 1th case. We're going to consider the sum from r equals 1 up to n plus 1 of our statement, cosine 2r minus 1 theta. Now, we're not going to write down the right-hand side, but we're going to say that this is equal to the first n terms. The n plus 1 terms can be thought of as the first n terms, 2r minus 1 theta, plus term number n plus 1. So this is outside of the sum, outside of the sigma. This is cosine. We plug in n plus 1, so we get 2n plus 2 minus 1, which is plus 1 theta. Okay. This first part is our induction hypothesis. So this first part can be replaced with, based on our induction hypothesis, we can replace it with this. So we now have sine of 2n theta over 2 sine theta plus our term number n plus 1, which is cosine of 2n plus 1 theta. Now, we're going to make a common denominator. To make a common denominator, I'm going to multiply this one, which used to have a denominator of 1, and I'm going to multiply it by 2 sine theta over 2 sine theta. Now, I hope you see what we can do here. They gave us an identity in the problem. They said to use this identity. When you see this, which I do right here, I can replace it with this. So this becomes, let's see if I can fit this in. The first fraction stays the same. Sine of 2n theta. The denominator now for both of them is 2 sine theta. And then the right-hand fraction becomes sine of a plus b minus sine of a minus b. So we have sine of a plus b. 2n plus 1 theta minus b, plus b, which is plus theta. So 2 sine n plus 1 theta plus theta. And then minus sine of a minus b, which is sine of 2n plus 1 theta minus theta. What ends up happening is if you do 2n plus 1 theta minus a theta, that's going to cancel out with this piece. 2n plus 1 minus 1 is 2n. So those cancel out, leaving me with just this part left over, which is exactly the n plus 1th version of the right-hand side. So the statement is true by induction. So those are two types of induction proofs. There's obviously more, but all induction proofs are going to follow that same three-step process. Base case, state the induction hypothesis, and consider the n plus 1th term.